here's the thing. So there's lots and lots of different programs in quantum gravity. I don't take any of them seriously. I think they all are, have serious challenges in that. They each begin with a kind of glimmer, a kind of interesting intuition. So every one of them, I think, has a kind of cool intuition that kickstarts the program. Then there's a lot of math, and then people have to say things about that math. And so now they're attaching what I think of as like proto-interpretations to the math, because you don't have fully worked out theories, and so you can't really attach a full interpretation to everything because you don't really know what's going on. But you kind of have an idea because you had that initial intuition about what's spark that triggered the theory. And so you'll start attaching all these concepts to different bits of math. And so then what ends up happening is people talk about, space and time discrete. There's the emergence of time from no time, and all of this kind of thing. And I've worked in it. It's very interesting, but I don't take it too seriously, especially because we just don't have more worked out interpretations or more worked out theories. And so when it comes to the kind of time aspect of it, I do think of a lot of it as sort of more, how to put this, it's more sort of extrapolation and thinking what you want to see in the theory than what is actually in the theory. And so I don't think we're really, I've got friends who work a lot on philosophical issues in quantum gravity, and maybe they take the kind of conclusions more seriously than I do. But I don't really see that you can take a general lesson from quantum gravity yet for time.
Craig Callender's 2017 book, What's So Special About Time, is widely received as one of the best books written on the topic. I really think it's one of the best books you can go to for the philosophy of time. In it, he tries to see if there's a possible reconciliation between the picture of time that we get out of our best physics, the various pictures of time we get out of our best physics, and the picture of time that comes across in our subjective experience. To do this, he consults not only the requisite physics and philosophy, but also the relevant cognitive science and cognitive psychology. Craig Callender is professor of philosophy at UC San Diego and co-director of the Institute for Practical Ethics. His work focuses on the philosophy of science with a focus on the philosophy of physics. Here, we talk about time, a little bit about quantum gravity, a really interesting paper he wrote on black holes and thermodynamics, and practical ethics. This is my conversation with Craig Callender. Just want to start off with what is the 2 times problem?
Oh, the 2 times problem. So I modeled that on Eddington's famous two tables problem. So Eddington said, well, look, there's the manifest table. It's solid, hard, certain color. Also has all sorts of properties, all these microscopic properties that we attribute to it. And yet then there's the table of physics. It's mostly composed of air. Your hand bounces off of it if you tap it because of electromagnetic forces, not because it's hitting a bunch of stuff. And so you have to be able to try to reconcile these 2 tables. And so I thought about when I was writing my book, What Makes Time Special, I thought about, the problem in a kind of similar way, where we have manifest time. And I was thinking of this as not just exactly like what we perceive, but more like the kind of model we use as we navigate our life through time. And so we employ this kind of rough and ready model, and I think it's pretty basic. That is, I think it's something. So I was imagining something really low level, not like our theories of cosmology in it or anything kind of really high cognitive. Uh, and then physics, and so physical time. Then I was thinking mostly just of relativity. I mean, who knows if relativity is the final story, but that seemed like the most natural piece of physics to use, because that was the only relativity is really the only theory that takes time as its target. And so that then made me think to use that. And so then the idea was, then how could I reconcile manifest time with physical time? And so I then was off to the races on this kind of Eddington like project. And yeah, and so then I think I tried to approach it in the way you would like the Eddington project, because I don't think physics by itself, as we without having reduced all of the other sciences to physics, you're not going to answer that problem with just physics. And so you have to introduce more sciences and more resources. And I think I begin the book, if you looked at it, then I begin the book with this discussion between Einstein and Carnap, where Einstein laments that he says physics will never satisfactorily answer the problem of the now, and he thinks this is what sounds like from the thing. He thinks this is a shame, a pity, a shame, and sad. And then Carnap says, yeah, but if you add more sciences, well, the way I read him is, if you add more sciences, then you can. And so in particularly, Carnap points to psychology. And so the second half of my book is a lot of cognitive science and biology in that.
Right. So yeah, I mean, even though you're integrating the special sciences, cognitive science, and psychology, you mentioned that it's still going from here to there. We're going from whatever the best physical theory of time that can be made out to the perceptual experience of time, rather than the other way around, which is important, because I don't know if the other way around has any real possibility to it.
So Bergson, the famous French philosopher, I mean, his PhD in the late 1800s was an attempt to go the other way around. And so you do sometimes see work in phenomenology and that, where you then try to get the time of physics out of the time of experience. And to be I mean, in their favor, in some sense, that's got to be what we're doing when we come up with physics, because we start off with all these observations, and the observations are done by people ultimately. And so in some sense this project happens, but yeah, the other way around is then a challenge. I mean, they're both challenges, and so I didn't think of the Bergson project as really having succeeded. And I don't know if the project I had going the other way succeeds either, but I give it my best shot, really.
It's a lot more convincing, is what I'll say. Okay, so before we proceed, just for people listening, do you mind giving a quick definition of manifest time? What are the components that make up manifest time?
Yeah, so what I think of as manifest time is well, really sort of three components. The way I mean, it could have started off many different ways, I think, in my book, but what I did was with the book was I thought, I'm just going to start off with the now, so that you think that there's this kind of special objective now. It's what's really happening. So us talking is now, and from that you then also divide the world into this kind of tripartite structure. Then there's the stuff before the now and the stuff after the now. But it's not just that some of it's before and some of it's after, it's that you attribute different properties to it. So I think of the past as settled, fixed, the future is open, ripe with possibility. And then, of course, you think that structure changes, it updates itself. And so the three components then are this kind of are the privilege now, the fact that it updates, and as it updates, it's carrying along a past and a future with different properties. You could imagine other structure in there. I mean, probably our model of time has more stuff. It's just that those are the things that seem interesting from the point of view of philosophy of time, because those are the features that are just hard to find in physical time, and that seem to be distinctive versus space. So no one thinks that the here, so we've got the here and the there, the left and the right. No one thinks that those categories carve up nature in some fundamental way, and we don't attribute different features of the world to the right. Then we don't say the right is fixed and the left is open or anything like that. And none of those things are important to us. I mean, the key thing with the manifest time is that, oh boy, that is really important to us. So it shows up in all of our language, thought, and behavior, and is arguably like a key part of what makes a human being a human being. So it's of interest to explain all that stuff.
Right. And like just as a side before moving forward, it's also true that that experience of time, like those three things in manifest time, are universal amongst people. Like there have been some claims from sociology and stuff that there's differences in time perception, but yeah.
So yeah, I haven't received. I thought I would receive more pushback actually on that than I have. I mean, maybe the people who would do the pushback haven't really seen the books, but yeah. So there's all this work on and cognitive linguistics, anthropology on variation of time, concept of time within human beings, but what I point out in the book is that actually most of that research actually indirectly is an argument for the invariance of manifest, or the universality of manifest time, because most of that work is sort of looking at ways we represent manifest time differing in different cultures. And so for English speakers in the in America, this direction is the future, that direction's the past. In other cultures, that direction's the future, this one's the past. Some of this work is super interesting because some of it, so we're used to representate, so these are spatial representations of time, and we're used to that. We in the US anyway, our English speakers are used to them being egocentric, but of course there are some cultures where they're topocentric. It depends on the local geography, and so it's very interesting to think about the conversation patterns, because like if we were facing each other, our futures, our spatially represented futures conflict with each other. Like I would point into your chest, or you would point into my chest. But of course, if there's a river in the village that determines it, then we both point in the same way for the past. And anyway, so a lot of interesting stuff. But all that variation, as far as I could tell, just shows that manifest time, at least in the way I'm understanding it, where it's a kind of very low level thing, is universal. You're not going to find people who think that if they hit a switch, it's going to change where they were born, or none of that is found. What is found also is the more high level of cognitive you go. So if we think of manifest time and just put in more and more cognitive theoretical stuff into it, well, then of course there's going to be massive variation, because there's even variation among top physicists about the cosmology, right? So if we throw in enough stuff, we'll have, and of course we'll find groups who have will believe in like cyclical time versus non-cyclical time and things like that. but that's all kind of high level theory, which wasn't really what I was aiming at.
Yeah, I agree. I really like the literature on timekeeping, like clock towers and things, and how they played a role. It's just about for people listening, about how when colonial societies brought clock towers into settler societies, they that created a new dynamic of how people interacted with time sociologically. But I think that is far different from like the manifest phenomenal experience of time versus having some social value or practices against around it.
Yeah, yeah. Yeah, I'm reading actually some book. I just started reading this book, which is on the kind of history of, well, transformation of timekeeping and that. Yeah, I love that literature as well.
Okay. Okay. So then we go from universal manifest time to try to find that anywhere in physics, and specifically go through relativity, well, classical physics, but relativity, quantum mechanics, and some of the approaches to quantum gravity. Uh, and there's nothing. There's no manifest time never pops up, and it's in fact hostile to the idea of manifest time.
Yeah. Um, I mean, I think, even if we just, so even if we just suppose we just stuck with classical physics, so there you've got Newtonian physics. There you have a well-defined simultaneity relation. So it's objective absolute, what things are simultaneous with what things. Even there you don't find manifest time. So sometimes people say, oh, manifest time got hurt by well, for special relativity, gets rid of an absolute simultaneity. General relativity, then you've got solutions where you can't even draw a single global global entirely space-like surface. And then you've got all these people saying in quantum gravity there's no time at all, and so then it looks like a kind of modern thing that there's this conflict between physics and manifest time, because those three successive alleged hits come in 20th century. But really, even if you're just looking at Newtonian time, uh, which time, that doesn't say which time is the now. It doesn't tell you that there's a difference between past, present, and future. So what I thought of it really is, I just think in terms of the whole problem is really you've got these dyadic concepts. So deixis is the word for pointing. And so, so if I think of it this way, I think of it like, well, physics gives us all these kind of different bits of geometry to represent space and time. So, distances, order, dimensionality, things like this. And of course that changes, so when we move from classical physics to relativity, it changes, and then maybe it'll change more with quantum gravity. Now, to actually use any of those physical models, then you need the pointing concepts. I need to then put in a now and a here and a left and a right and things like that. But the curious thing about time, though, is that we take those pointing concepts seriously with time, but not with space. And by seriously, I mean we take them to be objective. And so no one thinks that the spatial ones are objective, right? Like if I said, Ashar, pass me the salt, it's on your left at dinner. Well, what your left already just indicates that I understand that it's left and right is due to a dyadic center, your perspective, and it's just immediate that it's not an objective feature of the world. I mean, heck, when you're looking out at the world, you could sort of see your nose a little bit, right, spatially, right, in your so you know that there's this kind of your concepts of left and right and stuff are perspective, related to your perspective. But the weird thing about time is that you don't really like see your nose with time, And there's nothing indicating that the time, that the now, that these pointing features are anything but objective. And but yet physics doesn't require them at all. So even Newtonian physics doesn't require them.
Right. And I mean, like to get to an objective definition of time through Newtonian physics, relativity, quantum mechanics, and quantum gravity, like I'm totally lost. It just seems like a mixed bag of various definitions of time, and the work is still left to do.
Yeah, so I think even if so I go through all these times ways of trying, so it's all these philosophers and physicists who, because they think the problem is really about relativity, are trying to find something like simultaneity in relativity, or a kind of preferred foliation or something like that. And so I'm pretty skeptical of those things too, that they'll work in any way. Um, but even if they found something, it would be just as good. The best they could do is get something like classical physics, uh, and even then, that wouldn't really solve the two times problem, unless they could further show why that simultaneity that they want to dub the present actually plays the role in my experience of as the present, or explains any of my temporal experience.
Right. So even if you could find an objective, unified measure of time, you would still need to do the cognitive science and the cognitive psychology of why we have an experience of it in that way.
Yeah. Yeah, I mean, suppose that, you could solve the problem easily, if the way it's set up by some people, right? Yeah, I could say, Asher, just, tell me just grab some set of events and call it the present. And you say, okay, you draw a little circle on, you pick out a volume in a space-time diagram and say, that's the present. And I'll say, oh, well, okay, you've solved the problem, but you haven't solved the problem because, what is that present doing? How does it affect, why would human beings sense that thing, and why would it be um, important in any way?
Right. Right. Okay. Okay. Shifting gears a bit, then going to the cognitive science. What's the story that we find there?
A super interesting one. And uh, the first that I had when I started looking at the cognitive science of, because I was starting off with the present, so I was looking at the kind of construction of the present. So, well, if we're thinking about the way our experience is, we've got these kind of uh, experiences where things haven't yet fallen into memory, nor are they part of what's anticipated. And so we've got these subjective presents. And now, what are these things and how are they constructed? And there's a lot of work on this, and it's super interesting. And the first thing I thought of was, well, you could actually make a kind of like that argument in relativity against kind of the theories like presentism, which say that only the only the only the present is real. You could do a kind of psychology version of those things, because it turns out that no two people put together their subjective presence the same. So if I look at the way I'm putting together the present, it's absolutely remarkable. And instead of going through all the details, often in talks, I'll just give an example I use in the book, which is of this pilot who he had a kind of, I forget where the lesion was, but he had a small operation, and he was in the research paper. I think they talk about he was at home with he was at his daughter's house, and he was recuperating from the operation. And she came home from work and saw that he had taken apart the televisions, and because he thought that the audio and visual were out of sync. And then he was talking to her, and also noticed that it was her, and so then they noticed that it was him who's out of sync, not the televisions and stuff. And so it's interesting is that if you did a one of the kind of standard tests of when so you can measure subjective simultaneity in different ways by I could give you two signals with certain lag and ask if they happen at the same time or not. I can do a temporal order judgment, which one happened first. So there's all these kind of standard paradigms, that experimental paradigms that are used in psychology to look at subjective simultaneity. And what's interesting about him is that he was sound firster. So sound is slow, light is fast, but our ears are very fast and our eyes are very slow. If you had a signal at about 12 meters away from you that emitted light and sound, then if we took into account all those latencies, then it should hit your cortex at the same time when you're about 12 meters away. But of course, when somebody comes up close to you, their lips, the visual image of the lips still matches the sounds. And when they go far away from you, as long as you can still see their lips, they still match. So our brain is doing a lot of work in terms of matching the signals. Anyway, the retired pilot, he would hear. So if you came up to him and said hi, this could be wrong. I mean, viewers would have to go check. I could have it the wrong way around, but it's been a while. But I think he was a sound firster, and so he would hear you say hi, and then see your lips move, and he would consciously notice the lag. And so I think there was a 210 millisecond lag between his hearing you say hi and then the lips moving. And well, I always thought that it should be somebody like him, because I knew we were putting together things like this. And I always thought, well, if there's something the brain does, there's always the chance that the brain breaks in some way. And so I thought, well, there should be somebody like him. And then it was like an a priori prediction of this man. And anyway, this is a good example of we're all doing this. And so when the experimenters then put other people who did not complain about noticing a lag into the lab, I think about a third of people could consciously notice the lag between the audio and the visual and these kind of signals. And in fact, some of them were light firsters, some were sound firsters. And so some people who didn't notice it actually were like 200 milliseconds the other way. These are huge distances now. So if we added, so suppose you were 200 milliseconds sound firster and I was 200 milliseconds light firster. Now that we've got 400 milliseconds discrepancy between the two. So I'm trying to think of, so that's like almost, so in American baseball, that's almost the time it takes for the ball to go from the pitcher's mound to the catcher. So it's definitely in the conscious.
It's significant.
It's and yet we would not notice in a conversation that this discrepancy. I think it's just because the stuff that's interesting isn't labeled and moving that fast in front of us. And when we have things that are fast, so if I do this and we were in the same room, well, then the noise is produced when the finger hits the fat part of the thumb. So some of us might hear the noise when they're actually still processing the vision up there where the finger's up higher. Others where it's been sitting there for a little while. Yeah, everyone's going to agree that the sound came from the snap. No one's going to disagree really, unless I put a huge lag. And so we don't really notice that much, but we're all living on our own. So here's then the pictures of. So for that patient PH, if you asked them, what is your now, do you have a now, and is your now special? He'd say, yeah, yeah. But then if you asked him to catalog the content of the events that are in his now, it would then differ from yours, right? Because he's going to include, you're going to include, his daughter saying hi and her lips moving, both in the same now. He's not. But now if we actually had like really precise labels on all the events, we'd find that everybody's inventory of their special nows are different. And so they're not that special. I mean, so they're all, in some sense, they're all special, but it's like well, Steve Savitt in a different context, has this, Gilbert and Sullivan song in mind where, if everybody's special, nobody's special. So anyway, yeah, so cognitive science is then giving this kind of picture where of, basically how you construct these kind of nows. Takes time, there's a lot of interesting temporal illusions. Maybe it's different for different animals. In the book I keep joking, that maybe the giraffe has not only a long now, but not only a long neck, but a long now, because the nerves, the speed along the nerves is really not that fast, and their head is like 9 feet from their hooves. So as they're running and their hooves are trying to navigate the ground, they've got all those signals going back and forth. There's quite a big lag. I mean, I don't know how much of that is conscious versus, when we run, we're not conscious of adjusting our feet either, but we can be if we want to be, but we tend not to be. Anyway, you can then imagine that this kind of, you can then start to see, if you think of different animals and stuff, the kind of pressures that would lead to forming subjective simultaneity in certain sorts of windows for certain types of systems. And so then I think of this as this kind of evolved best way of if our food, if to get food or to run away from predators, we had to maybe in some other worlds you could imagine maybe it made sense to have a smaller, tighter simultaneity window. In others, a larger one. There's pros and cons of each.
Right. And it's a complicated evolutionary literature, I'm sure.
Yeah.
That makes sense. I think like you need a theory of self that seems adaptive, and then it seems adaptive to model that theory of self along the lines of manifest time, because it would help you escape predators and get food.
That's right. And then the other aspects, well, if that thing isn't updating, you're in big trouble if you're still processing the tiger roaring at you, and an hour later, you're not gonna, those creatures that have those that didn't update their simultaneity windows tended to die off pretty fast, I would imagine. And then you, of course, you have tons of resources from physics for then explaining other aspects, because you're throwing this embedded subject into the world, but that world has already got like a thermodynamic asymmetry, and it's got all these other features to it. The time-like direction is one-dimensional, the space-like directions are three-dimensional, and so so I think of all this kind of physics is already, well, one thing that's important is I think it's then a mistake to say that relativity spatializes time or something like that, because there's so many differences still. And then what you try to do is marshal how those differences would make it, show themselves in a person who is going around navigating life with this kind of, who's updating these kind of special presents. And then what they're going to find is that when they make decisions in those presents, they can affect they can affect things in the future, but not the past. And that's not due to them. That's due to living in a thermodynamic universe. Yeah.
Yeah, yeah, makes sense. They can't help but go through time. Right, right. Do you, I know you mentioned this in the book, but do you think there's any kind of a problem in how people in cognitive science and cognitive psychology model time? Because they're just kind of taking a straightforward view of time, and then there's the whole problem of, is it begging the question, or yeah, what do you think about that?
Yeah. Yeah, no, I get asked this all the time where, so traditional philosophers of time, they're brought up thinking about the debate as, well, I'm old enough so that when I started this, that, it was very much sort of language saturated debate where the idea was, can um, I get tensed language from tenseless language? And if I couldn't, then that meant, that in the metaphysics of the world, there was tense. That whole debate should be viewed as weird because, tense is a linguistic feature. And so how the heck you could go from a bunch of premises about language and then have a conclusion about metaphysics is, it just seems bad methodology. Um, then later, it gets sort of, that debate gets sort of updated a bit, but still, I mean, it's like a mugs game, so you don't want to play it because you're going to lose for sure. But it does, but losing doesn't mean you lose. That is, we know that you can't get, um, I can't get, I can't explain indexical language in terms of non-indexical language. And so if the whole game was set up so that, if your theory of time is wrong, physics is wrong, it's incomplete about time. Why? Because you can't get indexical stuff from non-indexical stuff. Well, that sucks because because we know you can't do that. And so by setting up the game that way, it's set up so that you always, the one side always won. So now, how does that relate to the question you asked me? That relates because, what I didn't do, and I just basically ignored because I found it just beneath me, was, the idea of trying to detensify all
Right.
language or remove all indexicals from all of language. And so people will say to me, well, Craig, you've got some nerve, you're using all this time from biology and cognitive science and psychology, and you didn't purify it. And well, and so what can I say? I just say, well, I fess up, that I didn't purify all of the language of all of the language of all of time, wherever time is used in all of science. But now, no, see, even if there was a serious objection here, that would then change things, because the argument, because now the argument would not be, so now maybe the argument would have to be something like, oh, cognitive science really requires tensed time, and now you have to, before your explanation can go forward, you need to detense it. Well, if that's so, that would then change the argument a bit. I mean, most of these experiments and theories I'm talking about do with just with clock time. And so if you could, so then you'd have to show that somehow tense stuff is sneaking in into clock time. Anyway, if I back way up, I mean, I do think, so I don't think you'd be able to do it. I am sympathetic to the view that we as representers kind of use tense. I mean, so they're not going to get it. We're not going to find a view of ourselves outside of ourselves where tense is completely removed. But on the other hand, that doesn't mean that you have to believe that it's some sort of metaphysical feature of the world, because we know we don't for space. Um, so I don't think that there's a special here, but of course there's also a here that's sort of this irreducible part of me, my representation of the world, and I can't get rid of that either. I didn't get rid of that in cog sci either, or biology, um, and yet we don't believe in it. So unless you have a really kind of strange view that there's your kind of tensor of space and personal pronouns, there's also the I and the Craig. So there are two of me, or yeah. So I don't have too much sympathy with that objection, but I hear it a lot.
No, I mean, uh, I think part of the challenge here it might just be sociological in that nobody really knows whose problem this is to deal with. Because on one end you think it's physicists, and then another you think it's philosophers, another you think it's cognitive scientists. But like just the volumes that you wrote on them, they had phenomenologists, they had physicists, they had philosophers, and you do need to go through all the muddy details to get the picture. And just to pose the objection to say that any one person needs to purify time to be able to use it. It's just that's an insane project to take on.
Yeah. But also the one that I think you're bound to lose, and for principled reasons, and it wouldn't. And since you already don't hold that standard to space and personal pronouns, then it seems unnecessary.
Right. Okay. So seeing the philosophy of time as this debate between tensed and non-tensed time then is not a helpful way to proceed anymore. Do you think we should shift away to just seeing cognitive time and then looking at time as the physics tells us to be?
Is the well? I think I misheard the. I didn't hear the beginning of the question. So there's the question: should we shift to cognitive time instead of manifest time?
No, no. The question is just that, like in my very novice understanding of the philosophy of time, it's kind of been this debate between tense time and non-tense time, or presentist and then eternalist theories. Is that characterization in itself wrong? And does it benefit from looking at the cognitive picture more clearly?
Yeah. So that's what I tried to do in the book, was just not really talk about tense or versus tenseless. And so yeah, there I well, I hope it came through, because sometimes the loudest statement is what you don't say. And so what I tried to do is, well, up until the end, I have go off against philosophy of time in the final chapter, but up until then I don't really talk about it too much. And yeah, it's because I think that that's not a very profitable way of thinking about the whole debate. So we've got this kind of manifest time model. It's important to us. Can we explain it? And not have everything be about, I mean, because we know, because the problem of the essential indexical, if we have that kind of hovering over us, that sort of tells us what things we can and can't, what things we can't expect to do. And so just don't setting up the project that way is just setting it up for this unattainable goal. And it's not that interesting. It's a kind of crazy goal when you step back and think about it. And so, but that doesn't mean that there's not something super interesting about time. I mean, I do think of it as like right up there with consciousness as one of the big problems. So yeah, so I purposely didn't talk about it much as a way of trying to show that you could still do philosophy of time without just talking about tense versus tenseless.
No, that did come across. What also really did come across was how serious of a problem time is, and how how interesting it is in comparison to consciousness specifically. Shifting gears a bit, in the various approaches to quantum gravity, this may be a really broad question, but what do you think the picture for philosophy of time is looking like?
I have, yeah, I don't really know, and well, I have opinions, but I don't really know. So here's the thing. So there's lots and lots of different programs in quantum gravity. I don't take any of them seriously. I think they all are, have serious challenges in that. Um, they each begin with a kind of glimmer, a kind of interesting intuition. So every one of them, I think, has a kind of cool intuition that kickstarts the program. Then there's a lot of math, and then people have to say things about that math, and so now they're attaching what I think of as like proto interpretations to the math, because you don't have fully worked out theories, so you can't really attach a full interpretation to everything because you don't really know what's going on. But you kind of have an idea because you had that initial intuition about what's spark that triggered the theory, and so you'll start attaching all these concepts to different bits of math. And so then what ends up happening is people talk about, well, space and time discrete. There's the emergence of time from no time, and all of this kind of thing. And I've worked in it. It's very interesting, but I don't take much of it too. I don't take it too seriously, especially because we just don't have more worked out interpretations or more worked out theories. And so when it comes to the kind of time aspect of it, I do think of a lot of it as sort of more, how to put this, it's more sort of extrapolation and thinking what you want to see in the theory than what is actually in the theory. And so I don't think we're really, I mean, I've got friends who work a lot on philosophical issues in quantum gravity, and they that maybe they take the kind of conclusions more seriously than I do, but I don't really see that you can take a general lesson from quantum gravity yet for time. So what I'm trying to say is, a lot of people go around saying, oh, well, quantum gravity is timeless, fundamentally timeless, and then you find this emergent time from it, or something like that. Is that really true? I don't know. The theories are so in their kind of baby stages still, so it's really hard to take that too seriously, because it could be that resolving some of the challenges that these theories face ends up putting a time right in at the beginning, or it could or not. I don't know, but we'll see. Other theories, they'll make the assumptions right away. So like something like causal set theory just assumes it's all discrete. They can't really say that they find discreteness. They just assume it. If the theory works, then we could do a kind of reverse generalize from it, and then say, turns out that was a good, if that theory, was massively successful, then we could turn around and say, oh, that's some sort of indirect evidence that space and time are discrete. But since we're like far from saying that theory is successful, we're far from doing that sort of look back and saying that it was really discrete. So some people think discreteness is a key to going forward. Other people don't. Other theories are like not that clear. There's talk about discreteness a lot, but then there's a lot of functions defined over continuous stuff. So it's kind of a free for all.
Yeah, the ontology is all over the place. Do you think there's any more clarity in the interpretations of quantum mechanics? There, you might have stronger intimations one way or the other about where time might end up.
Well, yeah. So I mean, quantum mechanics has a couple of big advantages over quantum gravity. You know, of course, we've got all the experimental evidence that and the theory, so we know the theories. We know the theories work, and the other thing is, you know, so there's certain bits of the theory that are um, crucial in all the different interpretations. And so you could look at some, you know, if we were looking at in the non-relativistic realm, we could look at the Schrodinger equation, and then now you could see that the Schrodinger equation uses, you know, what type of time does the Schrodinger equation use, and then it just uses a good old classical time. If we then go to relativistic quantum mechanics, you know, not general relativistic in quantum gravity, but special relativistic, then now we might have a kind of, you know, it's very hard to do for curved surfaces, and so that, you know, so mostly we'll be using a good old Minkowskian type time. And so, you know, now if there might then still be differences between the different interpretations. So famously, the Bohm interpretation is hard to make relativistic. I think some Bohmians would just be happy to live with that and just say, well, yeah, there's a kind of preferred foliation. With spontaneous collapse theories like GRW, you can have some non-Schrodinger, some modification to Schrodinger evolution. Maybe that modification matters. Sorry, I've got the dogs about to go off. Oh, false alarm. That was bad. And sorry.
No worries.
Okay, I think maybe we're good.
Okay.
So let's see, where was I? Oh yeah, so quantum mechanics, yeah. So well, we might, yeah. So there could be still surprises with quantum mechanics, because as we interpret those interpretations more, we might find out more about time, and there might be more disagreements on that. So we'll see. But there is, but there you at least you've got greater clarity, or at least with all the interpretations, you have a lot of clarity about what the formal stuff means. So the interpretations are interpretations of the formalism, and so you've got more complete interpretation of each of the main ones that I'm thinking about. And you have a lot of commonality in what they say about time, and you have, of course, all the experimental evidence vindicating the theory. So the situation is quite different, although still in a bit of flux.
Just as a side, are there any interpretations you tend to favor?
Yeah, I've been, you know, a kind of card-carrying Bohmian for my entire career, I suppose. So I did my PhD at Rutgers, and there were a bunch of Bohmians there. Took I think it was a year-long class in the math department with Sheldon Goldstein, who's one of the top Bohmians, and so I've learned the theory. And so I had in some way the weirdest education, because I actually took that I think a year-long class in the graduate class in the math department on Bohmian mechanics before I took quantum mechanics. And so I'm one of the few people in the world who learned quantum physics in a Bohmian way before learning the sort of normal standard interpretation, if we want to call it that, or standard mess that is usually taught in a physics class. Yeah, so I've had this. So I was almost, sort of raised a Bohmian because I learned it first.
Right. That's a really fun thing about talking to philosophers. They all have such weird paths to wherever they end up to.
Yeah.
Yeah. Okay. Shifting gears a bit. I saw you wrote a paper on black hole thermodynamics, and well, more generally, how thermodynamics and the weak analogy with the foundations of StatMac is maybe room to be skeptical. So you explain that a bit.
Yeah, so it's well, maybe if we step back for a second, so so you've got all these programs of quantum gravity, and then they're trying to find things that they want to that they need to explain, and people look to different features and think of them as these kind of clues to a theory of quantum gravity, and lacking any observational data for a theory of quantum gravity, a lot of the quantum gravity programs then try to see if they can explain these clues instead of actual data. So it's sort of like almost like a data substitute. And so a lot of groups try to explain then this theory, which is called black hole thermodynamics. And that black hole thermodynamics, points out all these different analogies between ordinary thermodynamics, which is, the science of steam engines and stuff like that, and entropy, temperature, pressure, volume, that kind of thing, and how efficient steam engines can be. Then point out various analogies with that, and then black holes. And that's fine as far as it goes, but then many people say it's not just an analogy, it's an identity, that these thermodynamic principles that explain why you can get only so much work out of a steam engine in some factory, and that also explains black holes, the features of black holes. So the claim is, I think it's important to see how radical the claim is. So the claim isn't just that black holes, that they're objects in the universe, and all the objects in the universe are thermodynamic, right? So stars, for instance, so before a star falls into a black hole, there's a hell of a lot of thermodynamics going on there, and very interesting thermodynamics. And so the claim isn't that, so of course the star is a thermodynamic object. If now the star, gets a certain mass and density, and such that it now turns into a black hole, well, it still is a thermodynamic object. But the idea is that there's these laws of black hole thermodynamics, and that these things are identical with thermodynamics. And when you first come across this, so this is viewed with almost universal assent. Everyone believes it. And when I look at it, of course, a lot of people say, well, that is really weird, because the analogies are mostly this kind of geometric features of black holes that are then being linked with thermodynamics. And then I think, well, in thermodynamics, I know why thermodynamics works, or at least I think I do, and it's because of statistical mechanics. I've got a bunch of little particles, or maybe it's fields, but I've got a bunch of little particles banging around, and there's certain ways of them being arranged that are more likely than others, and that's what's going on. And then that's why if I bring two iron bars together at one hot, one cold, they'll go to room temperature, because there's more ways of being in equilibrium than being non-equilibrium. But now there's, of course, nothing like stat mech for black holes. I mean, they try to invent it with a lot of quantum gravity stuff. So in quantum gravity, they'll say, oh, I've got a statistical mechanical explanation from string theory or something for it. But that black hole thermodynamics was around well before people believed that there was this identity, even before any of that stuff happened. And so what is the so it's a kind of a mystery as to why there would be this. And then what I try to do is, in the paper, is try to push on the analogy and try to show that it's not really that analogous. So if I really so now I could think about thermodynamics not as just the couple of its laws, but really think about thermodynamics like what actually it's saying, in a more full-blooded sense. And then when I do, you'll find that then you don't have analogies to a lot of what happens in black hole thermodynamics. So some of it is just such a weird puzzle, so shouldn't so volume figures importantly in ordinary thermodynamics, but then volume, uh, well, area is viewed as the temperature in black hole thermodynamics. Black hole area is viewed as the temperature, but then of course there's an analytic relationship between area and volume. And so shouldn't volume in black hole thermodynamics be volume in thermodynamics, be the counterpart of volume? But no, it isn't. So they'll suggest some other thing. And then you think, well, what if volume isn't volume and I mean, so just trying to think about it, it's really kind of hard to then think, well, how is this thing that's just one dimension off the area now is the now the entropy? And now I try to make sense of some thermodynamic law like PV equals nRT. Uh, it all kind of falls apart and it gets really messy. But then there are all these other issues too, which is that, well, I mean, one big one that I think would be recognized and accepted by physicists, which is what the heck is the black hole in the first place? Because the original black hole thermodynamics used just this sort of global notion of a black hole, which then has all these kind of weird properties. I mean, so the event horizon is not an observable. An event horizon might have just floated right between right. You might have just fallen into one, or we both might have just fallen into one without knowing. So it's not like in the movie Event Horizon where like there's a lot of drama. It doesn't have to be. This is more like an after the fact drawing on the diagram of figuring out where the event horizon is. Depends on what will happen later too, what falls in later. And so there's this kind of weird teleological feature to it too. And so what exactly is then the black hole? So what is the counterpart of the thermodynamic system? And so the paper just kind of point out all these kind of weird things if you really take the analogy to be an identity and you take that seriously. But I still get emails, so I think the paper has mostly been ignored, and a lot of people really don't like it, because it kind of challenges this kind of, I mean, it really is like a kind of dogma in the quantum gravity community, and it challenges that. But I do get, I just want to report here on the podcast, I do get, and in fact, I continue to get them, and in fact, I just got one a couple of days ago from physicists who teach thermodynamics and statistical mechanics. They send me emails and say, yeah, I agree with you. I've always thought it was all, not really thermodynamics or statistical mechanics. I teach that stuff and it just doesn't seem to be the same. So I agree with you, but I never felt like I could come out and say it.
Oh man, that's tragic.
So that warms my heart, is receiving these emails.
It surprised me that it didn't come from StatMech. That idea didn't come from, sorry, not StatMech, from quantum gravity. Because you would think that it's around because it's useful for people building their models. But no, it was there before.
Yeah. So Bekenstein and Hawking in the early 70s sort of noticed these kind of links. I mean, I think what's really going on is it's part of the information theorization of physics. So what you have is this idea that something falls into the black hole and now you don't know about it anymore. Well, so is that a challenge in any way? I mean, suppose I throw some laundry in the closet and I close the door. Now suppose the door is just such that it's got a really good lock, so I can't get by it. Does this mean that the information is lost to the world, or it's just lost to me? And so I think you have this kind of these kind of information loss type arguments pervading through quantum gravity, and it's all this kind of informationization of physics, where you think that the information loss in some way is a real challenge. but I don't think it need to be. It's just, you just need to be humble and realize that not all, you know, some observers won't have, even in principle, uh, you know, fully extended world lines might not have access to everything. I mean, I think there might be problems where, where we think of information not as just sort of inaccessible, but gone. So suppose we took a space time. Suppose you took like Minkowski space time and just cut out a hole in it. So there's just the topological, just gone. Some bits of it are gone. And now I've got now suppose I had a pair of particles in a singlet state. So they're in a superposition, and the two particles are going along, but then one just falls into the open manhole cover of space-time, so that it's just boom, it's just gone. Now, what is the state of the other one? Now I would, so if I just didn't know about that, I might trace out that information and give people put a state on the other one. But then I would think of that as just sort of epistemic because I don't know what's going on over there. But now if it really did fall into the open manhole cover of space-time, well, now it's not just epistemic, it's gone. But then we don't have a theory about how to write that other state. I mean, we'd still write trace out that information, but now that couldn't be viewed as just epistemic anymore. There'd be some kind of, objective ontological thing we'd have to say. But then that is just to say we don't have a theory of quantum gravity, really.
Yeah, you need to build some math and ontology to describe it. We just don't have it. Yeah. Okay. Well, just to end it off, I want to ask you how'd you get interested in ethics?
I guess a couple different things. So well, one is that I've always taught environmental ethics. So I taught environmental ethics, I think, for the first time in 1994 when I was a graduate student. And then when I came to San Diego, I started teaching it again. And so I've always had that interest. Part of it was because I was doing mostly just philosophy of physics, and I wouldn't even think about a space-time with matter in it, and never mind people and problems and societies and all that stuff. And so I wanted to have a kind of I don't want to say more meaningful footprint on the undergraduate teaching, but a kind of bigger one than just philosophy of science and philosophy of physics. Anyway, so I've taught for decades environmental ethics and other topics like that. But then I had this opportunity. I mean, I always kind of had it in the back of my mind to sort of not have a kind of separation between the teaching and the research in that area. But I never, for the longest time, I couldn't get myself worked up by kind of ethics issues because, well, enough to do research, because I would always just think, well, I'd look at some problem in society and think, well, such and such is just evil. And, it's just sort of bad politics or that. And it wasn't like a fundamental puzzle, like, so you look at Schrodinger's cat alive and dead, and you think, whoa, now that's a problem. And, whereas you look at some other thing, you think, well, this is because there's so much inequality in the world or something. And that's the solution, or something, that there should be more equality. But anyway, then I had an opportunity to, I was getting more and more, maybe it was just midlife crisis, but wanting to move more into this kind of applied area. And also applied philosophy of science, I think, has been on the rise. So if you think of work by Kitcher and all the people who've been influenced by Kitcher, you see a lot more applied philosophy of science. And so I always thought that there should be more of this work. I mean, look at all the misinformation now, science misinformation. I think applied philosophy of science is really important. Could have something to say about all of that. Replication debate, all sorts of things where you can see philosophy of science really mattering. So anyway, then I had this opportunity because various things going on at the university here, where I had this opportunity to found this new institute, the Institute for Practical Ethics. And so the sociologist John Evans and I, we co-founded this with our dean, Christina Della Colletta. And that's really kind of, that's a big job trying to set up a new institute. But what's really been really super cool about it is that it then puts me into contact with all of these people that I never would have been in contact with before. And so I meet all of these really interesting biologists working on mosquitoes, working on gene drives so that they can't transmit malaria. I work with people working on neurodiversity. I work with, people who work on, genetics and conservation, all these different areas. And so it's really, so if you find yourself in the right environment, then it's harder to resist the urge to do some research in these areas. And so that's, I've been taking up a lot of my time lately, is diving into all of that.
How's the experience of environmental ethics been? Seeing the state of the climate just devolve?
Yeah, I mean, that I always tell the students that's why I teach environmental ethics, because basically so I can meet them, because it's so depressing when you think about it. I mean, all the major emitters have done nothing. The more we know, the less we've done, in a way. And same with all the environmental problems. So once so if you look at like the plastic pollution issue, then what, as soon as it gets recognized as a real problem, what happens? We put out more plastic, and more and more and more and more. And so all the issues are just getting worse and worse and worse. But on the other hand, some of the students are just amazing, and they sometimes give me a little, a bit of hope. So I remember teaching at Scripps Oceanography in this kind of ethics boot camp, and one of the students, she went on just by herself and ended up setting up these marine marine protected areas where you're not allowed to fish and that, and some island in the Caribbean. And she by herself basically used her diving and biology skills, her social science skills, and her kind of schmoozing politician skills, and set up these, I think there are 2 reserves. And so, so you can't, got stakeholder agreement from fishermen and stuff like this, and got it all. And so you see a student do something like this, which, now these marine protected areas will be there, forever, maybe. And will have a huge effect on, well, I mean, not huge globally, but it'll have a pretty big effect for the island and the area. And you think, well, that was just one person who was under 30 who did it. And so, I try to, also, if you zoom out enough, if you look at some trends, so I don't know if it's really true, because there's there's all these different studies, but there's a lot of studies showing that economic growth has decoupled from emissions. And so then you're not in the position of telling developing countries that, oh, no, you have to stay in the, a kind of medieval time, where, pre-industrial time. So when you see that those things decouple, and you see the rise of solar and that, and other renewables, so then this maybe, I don't know, there's still going to be some serious impacts, I think, but people tend not to do things until it's almost too late. But it'd probably be too late for many, uh, but there are these changes afoot, which are to give a little bit of reason for optimism. But I agree with you. Every now it is overall like a punch in the gut.
Yeah, it's abject fear. Do the claim of a very primitive version of it is just that there's a debate between whether innovation, technology, and policy will save us versus whether you need coordinated political action to move things forward. Do you think that's a fair characterization, and do you lean in either direction?
Oh yeah, yeah. I don't think that the technology is going to be the
Yeah,
solution. Like
I agree.
I think, in fact, I think a lot of that is fed to us by the fossil fuel industry. So the fossil fuel industry is funding carbon capture in a big way. I think that's distorting the research landscape in the area. Why do they want carbon capture? Well, because it doesn't demand a decrease in emissions. So the decrease in emissions is changing your behavior in some way. Anything that doesn't require that, allows the status quo for fossil fuel. That's why. And so I don't think, so I think, we need to think not just does that tech. I mean, obviously, if somebody came along with these like vacuum cleaners that could just suck out CO2 in an efficient way, that would be, amazing, game changer. But of course, those things all need to be plugged in. And so and if the estimates are such that those things won't be able to be plugged in and actually have net emission reductions, when all is said and done, if the idea is that that technology isn't going to be around, so I don't know, sometimes I see different numbers, but like, 2040, 2050, well, then that's just saying, all that investment in that then is like, I'm not saying there shouldn't be some investment in it, but that if you're thinking technology is going to save you, if it's not going to start to save you into 2050, and you can just do nothing until then, well, there's a lot more you're going to have to save then at that point, because things are going to be so much worse. So it definitely has to be modifications, and you can't just think that the technology is going to save us.
I agree. I mean, like there's definitely micro technologies that are very helpful, and they have their applications, their niches. But I feel like the average person has a very grandiose idea of what massive technological innovation looks like. And I don't think it's new either. Like I think every generation had a pretty wild imagination for what the technology of the next generation will look like. And I think it's safe to say that's not going to happen.
Yeah. Or I mean, maybe another way to put it, which would be more maybe a different, would be like, in some sense, the technology to save us is already there. So we already have, I mean, what's happened with renewables is amazing. But if you just think of but now it's more like a kind of social infrastructure challenge, or a social norms challenge as well, a kind of norms and political commitment, and that. So yeah, I mean, you could be putting solar farms in many places. If you put, you look at the amount of money that gets thrown around for all sorts of different things. I mean, so Musk was going to buy Twitter for what? How much was that? I forgot how much that was. So
I can't remember.
it was huge, but if you put that much money into solar farms or
Yeah,
something,
yeah.
you make a huge dent in things real fast.